Welcome to this lesson. In this session, we will be discussing the components of an Arduino system. This is one of the most important topics because every project you build with Arduino depends on these components. An Arduino system is made up of three main parts: sensors, the Arduino board, and actuators. These three components work together using a simple process: input, processing, and output. Let's begin with sensors. Sensors are responsible for collecting data from the environment. They are known as input devices because they send information into the Arduino system. You can think of sensors as the human senses. Just like your eyes detect light and your ears detect sound, sensors detect physical conditions like temperature, motion, light, and pressure. When a sensor detects something, it converts that physical condition into an electrical signal that the Arduino can understand. Let's look at some common sensors in detail. Light sensor. A light-dependent resistor, also known as LDR, changes its resistance based on the amount of light falling on it. When the environment is bright, the resistance decreases, and when it is dark, the resistance increases. This change is converted into a voltage signal, which the Arduino reads using its analog pins. This sensor is commonly used in automatic lighting systems, such as streetlights that turn on at night. Temperature sensor. A temperature sensor measures the level of heat in the environment. It works by producing a voltage that corresponds to temperature. The Arduino reads this value and can use it to control systems like fans or alarms. For example, in a smart home system, the Arduino can turn on a fan when the temperature exceeds a certain level. Humidity sensor. This sensor measures the amount of moisture in the air. It is commonly used in weather monitoring systems and agricultural applications where controlling humidity is important. Touch sensor. A touch sensor detects physical contact. When you touch the sensor, it sends a signal to the Arduino. This is commonly used in touch-based control systems. Ultrasonic sensor. An ultrasonic sensor measures distance using sound waves. It sends out a high-frequency sound wave and waits for it to bounce back. The time it takes for the sound to return is used to calculate distance. This type of sensor is commonly used in obstacle detection systems and parking sensors in cars. Motion sensor, also known as PIR sensor. This is a passive infrared sensor detects motion by sensing changes in infrared radiation. When a person moves in front of the sensor, it detects the change and sends a signal to Arduino. This is widely used in security systems and automatic lighting. Sound sensor. A sound sensor detects sound levels in the environment. It converts sound waves into electrical signals. For example, it can be used in a clap-controlled lighting system. Flame sensor. A flame sensor detects fire or flame by sensing infrared light emitted by flames. It is used in fire detection systems. Pressure sensor. A pressure sensor measures force applied on a surface. It is used in industrial and mechanical systems. Now, all these sensors provide data, but they cannot make decisions. This brings us to the second component: Arduino board unit. The Arduino board is the central part of the system. It is responsible for processing the data received from sensors and making decisions based on the program you write. At the heart of the Arduino board is the microcontroller. This is a small integrated circuit that executes the code and controls all operations. Digital pins. Digital pins are used for binary signals, either high or low. They are used to read simple inputs like a button press, or to control outputs like turning an LED on or off. The analog pins are used to read continuous signals. Sensors like temperature sensors and LDRs send varying values, which are read through these pins. The power pins include 5V, 3.3V, and GND. They supply power to the board and connected components. USB port. The USB port is used to connect the Arduino to a computer. It is used for uploading code and also for powering the board. Voltage regulator. This component ensures that the Arduino receives a stable voltage supply. It protects the board from damage due to overvoltage. Crystal oscillator. This component controls the timing of the microcontroller. It ensures that instructions are executed at the correct speed. The Arduino board processes all incoming data and decides what action to take. Now let's look at the final component. Actuators. These components carry out actions based on the decisions made by the Arduino. They convert electrical signals into physical actions. Let's look at some common actuators. LED. An LED produces light when current flows through it. It is used for indication and basic output. Buzzer. A buzzer produces sound. It is used in alarm systems and notifications. DC motor. A DC motor converts electrical energy into rotational motion. It is used in fans, wheels, and mechanical systems. Servo motor. This actuator can move to a specific angle. It is used in robotics and control systems. Solenoid lock. Used in smart door systems for locking and unlocking. Water pump. Used in irrigation and liquid control systems. LCD display. An LCD is used to display information such as temperature or system status. Example of a simple Arduino project that contains all the three major components. In a smart lighting system, PI or motion sensor detects motion and send the signal to the Arduino board to process and turn on the light bulb. In summary, an Arduino system is made up of sensors, the Arduino board, and actuators. Sensors collect information, the Arduino processes that information, and actuators perform the actions. Understanding these components is essential for building any Arduino project. In the next lesson, we will begin working with sensors and build your first practical system. Thank you. See you in next lesson.